Today we're discussing angles and radian measures in section 9.2. So the first thing we're going to discuss is angles in standard position. All right, in standard position, the initial side happens here along the x-axis, and this is at 0 degrees. The direction then goes counterclockwise. That's positive direction. So when we are going, kind of draw a little note here, when we're going this way, that is the positive direction. Versus when we start at the x-axis and we go clockwise, that is a negative direction. So the initial side is on the x-axis. The other ray, the other side of the angle, is called the terminal side. And we rotate that about the vertex, or about 0, 0. So an angle is in standard position when the vertex is at the origin and the initial side lies on the positive x-axis. So it looks like this. So we are going to draw some angles. This wants us to draw an angle with the given measure in standard position. All right, so keep in mind that over here, this would be 0 degrees. And then we would have 90 degrees, 180 degrees, and 270 degrees. So if you think about it, 240 is all the way around to 180 and then another 60 degrees. So about right here. So we are going to go ahead and draw both sides. I'm going to pick a different color just to make it stand out a little more. So do draw your initial side right here. I tend to do it in pen if I'm doing it on my paper. I sketch out the angle itself, all the components in pencil, and then highlight the angle by showing that. Now you show the direction by putting an arrow on this kind of circle that shows which way it is turning. And so that is 240 degrees. So let's go ahead and see if I can make that stand out a little better. So let's set up our next one. So for 500 degrees, right? 500 degrees is 360 degrees, then plus another 240. So it's going to first go around the circle plus another 140. It's going to first go around the circle one full time, and then another 140 degrees in a positive direction. So first I draw showing, okay, that's 360 degrees plus another 140. So there's plus another 90 and then plus another 50. So about in here, and I'm not perfect, but we're close enough. So we want to draw the arrow on that spiral showing which direction this is going in. And then, like I said, I'm going to go ahead and just kind of make this stand out. So here's your initial side. And here's your terminal side. So you could use a highlighter or a pen when you do this on your homework. And that is 500 degrees. All right, and then this one wants us to go negative 50 degrees. So we are going to start at 0 degrees, and we're going to come down 50 degrees. So I just get a good estimate. I know it's over halfway because halfway would be 45 degrees, half of this quadrant. So I show this. And then I'm going to go ahead and show my initial side and my terminal side and make sure I show both. And so that's negative 50 degrees because the direction does matter. Okay, so this one wants us to find one positive angle and one negative angle that are coterminal. So coterminal means that their initial side and their terminal side are in the same place. That's what it means to be coterminal. So basically, every 360 degrees, you return to the same position. So you can add or subtract 360 degrees as many times as you want to have a coterminal angle. So, for example, just to kind of show you, if you picture where this is at, negative 45 degrees is right here. This is negative 45 degrees. Make that show up. So, if you instead started in the same place, and let's say maybe you went the other direction all the way to the exact same place, then what that would do is that would be, instead of going negative 45 degrees, I would have to go around 315 degrees. Now, that would be the exact same placement of the initial side and the terminal side. They technically are different angles because direction does matter, but they are in the same place. And that's what a coterminal angle is. So you can add or subtract 360 as many times as needed. So if I add 360 to negative 45, then I'm going to get 315 degrees. And 315 degrees is in the same location. I could add 360 again And I could get 675. That's also in the same location. I can also subtract 360. So if I subtract 360, then that's negative 405. Negative 405 degrees is in the same location. So those are coterminal angles. So you can add or subtract 360 as many times as necessary to get other coterminal angles. So like on this one, this is 395. So if I subtract 360 once, then I'm going to get 35 degrees. That's coterminal with 395. I could subtract 360 again. I could take the 35 and subtract 360 another time, and that's negative 325. So negative 325 degrees, 35 degrees, and 395 degrees are all coterminal. They will have their initial side and their terminal side in the same location. Okay, if you would like to try the monitoring progress, go ahead and pause this video and do so. I will come back with the solutions in just a moment. Okay, so we're going to take a look at example 3. So on example 3, it wants us to write the radian measure that is equivalent to each degree. So zoom in a little bit here. As you can see right here, the radian measure that's equivalent to 180 degrees is pi. So 180 degrees is equivalent to pi. This is the same concept as like measuring a distance in miles versus kilometers. Both are perfectly fine distances. They're just two different forms. One's metric, one's standard. Well, we have degrees and we have radians. So we have this, and if we want to go ahead and we want to think about 180 being pi, then 90 is half of 180, so 90 would be equivalent to half of pi, or pi over 2. So if we then think about 0, 0 would be at 0 pi, or just 0. So then 45 is a fourth of 180. If you think about this is pi, 45 is a fourth of the pi, so it's pi over 4. So then think about how 135 is 3/4 of the pi. You see it's 3 sections, 3 of the 4 sections, so it's 3 pi over 4. So then 4 pi over 4 is pi, and this is 5 pi over 4. Another puts us at 6 pi over 4, but that reduces to 3 pi over 2, or 1.5 pi, which makes sense because 180 is pi plus another half pi, but we call it 3 over 2 pi. The next section would be another section would then be 7 pi over 4, because now you have 7 of the 4th pi sections. Remember, each of these are worth a fourth. So now you have 1, 2, 3, 4, 5, 6, 7. And then this would be 8 pi over 4, which simplifies to 2 pi, which hopefully makes sense because 180 degrees is pi. Well, 360 is twice of that, so it's 2 pi. Now let's look at it with degrees that are divided up by 30s. So once again, we had this is going to be 0. Oops, sorry. So this is 0 over here, and then this is pi. Okay, so in that case, we have taken pi and we divide it up into sixths. So this is, right here is 1/6 of it, so it's pi over 6. Now then this amount right here is 2/6, which is the equivalent of 1/3. So that's pi over 3. This is still halves, this is still pi over 2. And then now we have 4 of the 6 sections. So 4/6 is 2 pi over 3. And then another 6 makes us 5/6, or 5 pi over 6. So then carrying on with that, we have now 6 out of 6 is pi. Now there's 7/6, so 7 pi over 6. Now there's 8/6, so 8 pi over 6, but we're going to go ahead and rewrite that as 4 pi over 3. We want to simplify it. Oops, sorry. All right, and then we are going to have, right here, we have 7, 8, 9 pi over 6, which is 3 pi over 2. We have that on our other one. And then 10 pi over 6, which is 5 pi over 3. And 11 pi over 6. Last but not least, 12 pi over 6 becomes 2 pi, and that's a full 360 degrees. Now, just kind of point out some commonalities here. So I kind of think about this as 60 is pi over 3. And then if you think about multiples of 60, 2 times 60 is 120. That's 2 pi over 3. All right, 3 times 60 is 180. 3 pi over 3 is just pi. 4 times 60 gets us to 240. That's down here. That's 4 pi over 3. 5 times 60 is 300. There's 5 pi over 3. So now think about in 30s. 30 is pi over 6. So if you times it by, say, 5, 5 times 30 is 150, and that's 5 pi over 6. Or if you go ahead and take it times 7, 30 times 7 is 210, and then pi over 6 times 7 is 7 pi over 6. So there really is a pattern. I also, if this helps you, will point out that notice that these right here are 30s, and then they are all over 6. And notice that our specifically multiples of 60 right here, kind of your middle x, are all over 3. I think that helps to remember. I would really suggest there are a ton of videos out there on YouTube of how to remember these different degree to radian measures, kind of your basic ones that we see here. And I'd really recommend watching them. They have some good just kind of things to help jog your memory if you're stuck. As we use these more though, I think you'll be very familiar with them. Okay, so how you convert to degrees to radians is you just multiply by pi over 180 if you have the degrees and you're getting radians, or 180 over pi. Honestly, I just remember the ratio and then I figure out what I need. So what I mean by that is if I have 120 degrees, then I multiply by pi over 180 degrees, because I think about that as the degrees essentially are canceling out. So 120 over 180 is going to be 2 thirds is what it simplifies to. So it's 2 pi over 3. And we write it like that. We don't usually write 2/3 pi. So this one is negative pi over 12. So we're going to times by, I know that that's in radians, so I need degrees on top. So 180 degrees over pi. So the pi is going to cancel out. And I'm going to have negative 180 over 12, which I can just go ahead and use my calculator to do. And so I get negative 15 degrees. So then here I have this in radians. It doesn't have a degree symbol. So I'm going to times by 180 over pi because I want degrees on top. So if you think about this as this is degrees, this is radians, and we have radians here, the radians will cancel and you're left with degrees. That's how I think of it in my head. So that's going to get the pi's to cancel, pi on top, pi on bottom. 5 times 180 divided by 4 is 225. So it's 225 degrees. So think about this one as negative 40 degrees. So times pi radians out of 180 degrees. Basically what I'm saying here is the degrees will cancel and you'll be left in radians. So if you simplify negative 40 over 180 as a fraction, it's negative 2/9. So that's negative 2 pi over 9. Okay, this is the unit circle that we will cover in the next video of today's notes. So here's the formula for arc length and area of a sector. Please keep in mind that r is the radius, but more importantly, theta is the angle in radians. This formula only works when we are in radians. So using these formulas, I jotted them down over here so we have them right in front. A softball field forms a sector with the dimensions shown. Find the length of the outfield fence and the area of the field. Okay, the outfield fence is right out here, and so that's going to be arc length. So the first thing we're going to do is we're going to have our radius, which is 200, times our angle. Our angle is 90 degrees, but we know that 90 degrees is equivalent to pi over 2 radians. So we're going to use pi over 2. So when we type that into our calculator, we find out that our fence is going to need to be approximately 314.2 feet long. Now for our area, we're going to go ahead and we're going to do 1/2. Our r is 200 squared, and our theta is pi over 2. So if we go ahead and we type that in our calculator, we have that our area is about 31,416 feet squared.